A very good morning to everybody. My name is Martin Garratt. I'm Chief Exec at Cambridge Cleantech, and a very warm welcome to our event on innovative solutions for tackling plastic pollution. This event is part of a series of events that we're undertaking, which we look at how we can help, through our members, achieve the United Nations Sustainable Development Goals, or SDGs. And this is very much in association with one of our associate fan members that you can see on the screen there, Cheeky Panda. So welcome to Chris, who'll be saying a few words in a second or two. This particular event is focusing on how we can help achieve SDG 12, which is responsible consumption and production. And of course, not surprising, the SDG 14, which is about life below water. So let me just mention a couple of points on housekeeping before we progress. You've probably just heard that we are recording this event, just so that you're aware of that. Please can you keep your microphones on mute whilst we undertake the presentations. But if you do have questions, by all means put those into the chat box and we'll try and pick those up at the end. And we'll also be having some breakout rooms where we can continue the conversation once we have heard from the presenters. And just a bit of an advertisement from myself as chairman. I'm using my prerogative. We have some other upcoming events. Probably best to take a look at our website to see all of those and our events page. But just by way of example, on Thursday this week, we have smart solutions for home energy management systems, which is part of our retrofit housing special interest group. We have access to finance for innovators in the UK's green sector. That's taking place at the Barclays Eagle Lab in Cambridge. That's one of the Barclays Eagle Labs which is focused on clean tech innovation. It's a part physical event, which is actually fully booked, I'm afraid, because there's only so many places available there, but you can join us on Zoom. Then we've got other events after that before the summer break, such as doing business in the USA on the 1st of July. So just a quick advert from me. But going back to today's event, we've got a range of speakers who'll be looking at those key sort of themes within this overall area, which is about reduce, reuse, and recycle. But just to say a few words of opening, I'm pleased to welcome Chris Forbes, who's the Chief Exec at Cheeky Panda, one of our associate founder members, who's working with us on this series of events around the SDGs. And you're going to say a few words, Chris, I believe, about how we can influence and create impact in relation to those sustainable development goals. Chris, over to you.
Hi, hello everyone. Oriane, can you put my slides up?
Yeah, just give me a minute.
Or I can do them if you want. Do you want me to do them?
Yeah, sure, why not?
Hold on. All right, okay. It's just a just a very quick introduction. So, for those of you who don't know who Cheeky Panda are, we are a tissue and hygiene product disruptor. So we use bamboo, the world's fastest growing plant, as an alternative to cutting down trees and deforestation. So, just a little way of background. You know, myself and my partner Julie created this business. And you know, if you've got literally the world's fastest growing plant, why are you taking something that takes so long? It's particularly in a world of stretched resources. So our values are to innovate, create new products, create new packaging, create impact, which we'd like to measure. I think we've saved about 250,000 trees to date by people not by people using our bamboo products. And our job's to inspire, and that's kind of why I'm part of this group, is to you know, help show other people that change is actually achievable and deliverable. So this is a problem. I think we're all familiar. I think it's also good to actually look at the world's biggest single-use plastic waste producers, and the stuff that we can do about this. You can look at some of these companies, and we can think, well, actually, is there alternatives that we can use? Certainly, from our side of things, we now have one electric car and one hybrid car, and we use solar energy. So if we can try and get off oil and gas, which is the world's biggest producer of plastic, then the quicker we can move to a better world. and also the companies, I think, when you look at, do you need to drink drinks from Coke or Pepsi or Nestle or Danone? Everything seems to be wrapped in plastic these days. And actually, if you look back sort of 30, 40 years, it wasn't wrapped in plastic. So the plastic really has become something that's a phenomenon in the 80s, 90s, and the last 2 decades. But, if you go back into, the 70s and before, everything was reusable. So it's kind of gone full circle. We've done it before. The world population isn't much different. So there's no reason why we can't go back to that. And globally, we produce 381 tons of plastic waste every year. This is the rate we're currently wrapping things in plastic. Is set to grow by 60%. Over 2 million tons of plastic packaging is used in the UK every year. Less than a third of this is recycled. It also produces lots of carbon, right? For every 1 ton, it's 2.5 tons of carbon dioxide. We don't properly recycle in the UK. We ship a lot of our plastic off. So while you might think you're recycling by throwing it into your recycling bin, actually that's not the right answer. The right answer is to try to get off plastic. So we've got to tackle some of the myths around plastic as a material. And you can't keep recycling the same thing forever. So what we need is new products that are made out of plastic. Now I'll give you a specific example. Our toilet roll and our kitchen towel were wrapped in plastic when we started. And in 2019, we took the brave decision to switch, not knowing if consumers would buy the product. So as our most popular line, our most profitable line, and then suddenly we decided, well, we're going to change it because it's the right thing to do. And by doing that, in our category, we've saved about 20 tons of plastic, which equates to around about sort of 50 tons of carbon dioxide. So yeah, classic example about, and this is our 48 rolls that we do. So again, it's kind of like, if you look into a supermarket, pretty much everything in tissue and kitchen towels wrapped in plastic. It doesn't need to be. We get very little waste returns with these types of products. So as a very real world example about how you can actually not have deforestation products wrapped in plastic, and actually there's better solutions out there. So my conclusion is less of this and a bit more of that. And with that, I'd like to pass on to the next person.
I think that's me. Thanks, Chris. Am I correct? That is me.
Yes, that's you.
That's brilliant. That leads on perfectly. I'm just going to share my screen. Okay, so hopefully that's come up there. You can see that okay?
Yes.
Okay, so that leads on perfectly. So as a marine biologist, I'm really quite happy to see those happy pictures of the ocean in your slides there, Chris. So I'm going to talk to you a little bit today about our plastic pollution pandemic, I like to call it, impacts of plastic, and also what opportunities we have going forward. So for the last 9 years of my life, I've been researching the impacts of plastics, that's both conventional and also biodegradable plastics, in any forms. So everything from plastic bags down to microplastics, microbeads, glitter, all sorts of things. Cigarette butts are another big bugbear of mine. They are a type of single-use plastic. They're not always categorized in that way, but they should be. And that's something that I'm working on at the moment. If anyone wants to speak to me about cigarette butts, please get in touch. As a marine biologist, my work has primarily been looking at impacts on the marine system, but I have also been working on freshwater, terrestrial, agricultural kind of systems, and also human health. So kind of covering as much as possible. And in my research, I use my research to advise businesses how they can reduce their plastic footprint. So DP World London, I'm a scientific advisor for them, and also other policy makers as well. So I'm going to talk a little bit about how we got here. Short, very, very brief history lesson. What impact does plastic have? So why should we care about it as a problem? And then what can we do about it? So you've all heard of Bakelite. My nan had a Bakelite telephone. It's quite a nice object, actually. This was invented actually by accident in 1907. Leo van Bakeland actually dropped kind of phenol and formaldehyde on the floor, and he sort of thought, that's funny, it's kind of mixed into a sort of resin. This resin was used mostly, it wasn't single-use items, it was actually luxury items. So it wasn't kind of a bad material, it was very useful. And he dubbed it the material of 1,000 uses, and he's got the little infinity sign there in the logo. But this wasn't really single-use, and it wasn't for the kind of convenience items. It was really in the 1960s, Earl Tupper, you've probably heard of Tupperware. He invented Tupperware made out of polyethylene in 1957. He's quite an interesting guy, so from an innovation point of view, it's quite nice to just reflect briefly on Tupper. It's a little quote up there from him. The fruits of life fall into the hands of those who climb the tree and pick them. So you've got to get out there and grab hold of what you want. You can't be passive and just wait for it to come to you. But the thing about Tupperware was that this really started people realizing that plastic can make life easier. You can also use it to store food to, it increased the lifespan of food, which is a positive benefit of plastic. But it's the way that it's used that is a problem. Just a brief note on Earl Tupper. He wasn't always successful. He failed for about 30 years in his career before he got successful with Tupperware. This is one of his early inventions. The non-drip ice cream cone, the multi-level non-drip ice cream cone. Wasn't successful, but he kept trying. Before that, in 1926, he invented the fish-powered boat. Also, for some reason, I don't know why this one didn't take off, but as a marine biologist, I don't even know what species that is meant to be. Hasn't got any pectoral fins. But yeah, so try again. If you fail, you'll succeed. I think Tupper's quite an inspiring character. But the problem is that since then, and as you said, in the kind of 80s and 90s, our dependency on single-use plastics has been rising exponentially. Dependency on fossil fuels as well. So about 368 million tonnes in 2019, 2020. And this is still increasing now. And of course, since the pandemic, we actually become more dependent on plastic again. The majority is for packaging, as you're already aware. It is useful. It's lightweight. You can save carbon to some extent. It depends on what you're using it for, of course. It's quite durable, versatile, recyclable. I mean, as you mentioned, recyclability isn't the be all and end all. I think it's about 9% globally that we're actually recycling, and the efficiency isn't great. There's a lot of work to do there. So as you were saying, Chris, it's not necessarily, a lot of it's wish cycling. So unfortunately, it's the way that we interact with plastics that's the problem. It's this throwaway society. And people in the post-war era actually wanted life to be simpler. They didn't want to have to mend and make do all the time anymore. They wanted life to be a bit easier. And you can understand that, a few more modern conveniences. But of course, we've taken that to the extreme, and you can't go outside of your house without interacting with plastic in some way. It's just impossible. And because of that, it's the most common litter item. This is the Ocean Conservancy cleanup data. 75 to 90%, usually about 85% in most habitats of the litter found is plastic. Some of the big contenders, you've always got your cigarette butts up there, plastic bottles. You can see a lot of this is packaging items, so that's where a lot of the problem lies. But of course, also big fishing nets get lost at sea. We shouldn't discount the huge impacts that they have too. There's a lot of different plastic litter in the environment. If we don't do anything, the problem with plastic is that it's not the amount that we're losing every year, it's the fact that it doesn't disappear. It accumulates, it's building up and up and up in the environment. By 2040, we could have 600 million tonnes of plastic in the ocean. So this isn't even talking about on land. It's the equivalent to 3 million blue whales. Now, to put that in perspective, as a marine biologist, I tell you that I think there's about estimate 10 to 25,000 blue whales actually alive at the moment. So 3 million of them, yeah, it's quite a big number. So even when it does break down, of course, it persists. It's a legacy pollutant. It persists as microplastics. So from breakdown from the sun, from mechanical abrasion, from organisms breaking plastic down, it can persist as microplastics. And these are actually the most abundant form of solid waste on the Earth. We are living in a plastic planet. This picture is a little bit busy, but it's just to show you that, this is a problem. You'll see the pandemic litter there in the bottom left as well. The map on the top left is actually from a website called Litterbase, which is run by a colleague of mine, Melanie Bergman. And you can go there, it's all free, open access, and you can click and see, what's kind of going on around your area if you want. This is based on almost 1,400 publications in the literature. The areas that don't have plastics, probably just because we haven't sampled there. I'd be very surprised if there's anywhere that doesn't have plastic contamination. That would be more impressive to me than people finding it. It's been found in the human bloodstream recently, lungs, human placenta, It contaminates us as well as the environment. Why do we care? So contamination on its own isn't enough to make policymakers do anything. We need to know what impacts it's having. Plastic is a double-edged sword. You've got the physical contamination, the actual material itself, but then it also leaches. You've got all these additives that are added to give it its flexibility and its long-lasting properties. And when it's in the environment as litter, it can actually absorb other persistent organic pollutants. And in that way, plastic can become like a kind of toxic pill if it's swallowed by organisms. So you've got both of these things to contend with. The impacts, once again, Melanie Bergman's team have looked at the impacts globally. Almost 4,000 species that we know of. I'm sure that's not the comprehensive list. This is just the studies that have been done so far. So, there's impacts on organisms that are obvious, like entanglement from ghost fishing, from big fishing nets, down to organisms eating meso and microplastics. This obviously can have an effect on their, it can actually make them feel like they're full, that kind of satiation feeling, they can eat less. But there's lots of sublethal responses, like organisms not reproducing as much and behaving differently. There's a huge plethora of impacts from plastic pollution. We tried to summarize it in our recent United Nations Environment Programme report. I won't talk you through all this, but it's recommended reading and it is free to read if you want to have a look at that. In terms of economic costs, it's obviously costing billions every year as well in terms of cleanup costs. Impacts on ecosystem services, difficult to evaluate, but there's alterations to nutrient cycling. The carbon cycle is altered in the oceans because of microplastics. Huge range of impacts, even things that you wouldn't think about. So impact on the mental health of humans. When you go to the beach, if you see a load of litter, there's been studies done that have shown that it makes people less happy. So that restorative effect of going to the beach is lessened when you've got a lot of litter. So a huge amount of impacts. Late, we kind of at the end, we can't do anything else about it. It's too late. It's too late to remove it all. There is a huge amount there. We're not going to get it all out. It's impossible, and you'd end up causing more damage if you tried, depending on how you do that. This is a little graph from a science paper from a colleague called Winnie Lau. The red line is your business as usual. So if we do nothing, we're going to have this amount. What is it? About 80 million tons per year. And then we've got the green, blue, yellow, and the purple lines are different scenarios of change. So changing our waste management, the blue line, improving recycling, the green line, reducing and substituting is that yellow line there. And then a full systems change is what we really need. And then we can reduce, down to about 20 million, which is going to be a huge improvement. We can't get to zero. We need to accept that. If we do nothing, this is kind of what we might end up with. We're still going to have about 20 million metric tons leaking. This is just the ocean, by the way. There's going to be more leaking into land. 2.1 billion gigatons of carbon emissions and such. If we do make a full systems change, which is detailed in the Pew Trust report, which is an excellent report, we can have a much more positive picture going forward. So 5 million metric tons of leakage. Like I said, we're not going to get to zero. So we need to focus on what we can do to reduce the impact. Actually, more jobs. And more kind of green jobs, if you will, as well, and far less in terms of carbon emissions. So this is not going to be done without global action. This was in Kenya at the United Nations Environment Programme meeting on plastic litter in 2020, just before the pandemic. That's me there with Professor Jacqueline McLeod. She was the lead author of the report. I was one of the lead authors. We brought together global opinions and issues and tried to work out what we can do and made a lot of recommendations in the report from pollution to solution. This and a lot of other reports and a lot of work by a lot of people led to the global plastics pact coming through, the treaty. This actually came through this March, extremely exciting. This is a legally binding treaty. It's been signed by 175 countries. So there is change coming. And I think change from a kind of top-down perspective. What shape that will take is unclear at this point. But from our perspective, in a science paper science letter that we wrote recently, there's certain things that we can't get away with. We do need to reduce production. It's not what the plastics industry wants to hear. Well, we still need plastic, but we don't need as much of it as what we're using. We need to reduce production of virgin plastics. We need to reduce demand. So obviously that's increasing things like reuse. Substitution where appropriate. This might include things like changing from a multi-layer packaging to a single, to a mono layer. Things that are easier to recycle. You know, the solutions aren't always complicated. Of course, downstream actions, improving collection, improving recycling, you know, where possible, where it makes sense. And of course, moving towards a robust circular economy. And if we're talking about bioplastics, we want a robust circular bioeconomy as well. We don't want a one-way system for any of this. That's our opinion as from a scientific viewpoint. This is exciting because there's a lot of opportunity for innovation, right? We've got a huge range of different solutions, from redesigning clothing, you know, making textile more durable, tire particles, one of the most common types of microplastics, you know, redesigning, substituting, as you were talking about, Chris, with the more paper-based and the bamboo-based sustainable paper, you know, reducing waste, exports. There's a huge range of solutions here, which we're going to hear a little bit about today from some of our excellent speakers in a moment. So one thing I'd like to end on is we should be collaborating. And I think often environmental scientists like me get forgotten from this collaboration picture, but I think we offer a really important contribution in terms of looking at the environmental risks, you know, comparing the risks of your solution to what's happening now, kind of risk assessment, and talking these things through. So I think having an interdisciplinary team and collaborating is the way forward. And that's it from me. Thank you very much.
Thank you, Dannielle. And so after you, it will be Thomas from Greenr.
Cool. Let me just. Sorry,
I need to stop.
It's all right. I think I can sort of force you.
Okay.
It gave me that option. Hi everyone, thanks for that brilliant opening from sort of Martin, Chris and Dannielle, really in depth and great to see some of the research that's been done there, and of course the plastic treaty, which has been sort of been pushed by some of the organisations I've worked for, but also just the sort of global scientific community. Of course, thanks to Cambridge Cleantech for organising. Before I get into greenr.co.uk, I do want to give you a bit of context as to who I am. Some of you, I'm quite new to Cambridge Cleantech, so I thought I'd give you some context there. This isn't my first rodeo dealing with plastic waste. I've been sort of hands deep in it for years, unfortunately. After more than 5 years working for the world's largest independent environmental organisation, Greenpeace, I was actually tired of seeing this rubbish heap mounting at the end of each event that I worked at for them. So I actually started my first company, Festovers, to collect and upcycle leftover festival tents. About 1 million festival tents every year around the world are incinerated or put in landfill. Each tent is the equivalent of about 8,750 plastic straws, so you can see there's a problem there. We were actually the first company to be specifically contracted to collect tents at scale compared to sort of previous charities and scavengers. And Festovers was super successful, but it focused on dealing with the symptoms of that bigger problem, which we've been talking about, which is we need to sort of reduce at source and buy better to begin with. So when the pandemic hit, we went to the drawing board, and because there were no festivals, of course, and we came up with a name and premise, which was Greenr Sustainable Shopping Made Simple. We got to work, and after a year of sort of a year and a half of thorough research, planning, and sort of bringing on our tech lead and co-founder Emma, we've now got an engaged consumer base and game plan to sort of capture and change that market of consumption. So I'm a second-time founder with sort of 5 years of experience with Greenpeace, engaging thousands of people into that movement and lobbying governments and organizations. I also actually study a part-time MSc in climate change at the UEA, which is top-line global course, giving me that sort of unique cross-sectoral expertise. Hugo is an award-winning marketer and brand designer, having led digital marketing for multi-million-pound EU-funded environmental projects. He was actually also lead officer for 2 award-winning COVID response campaigns, government campaigns, which some of you probably saw being in East Anglia. And Emma is a full-stack web developer trained in Silicon Valley, and she's worked in a number of high-paced, sort of fast-paced startups, from ed tech to leisure tech. So just to give a concept of adding to the problems which we spoke about, less than 10%, of course, of everyday plastic, being the plastic that things we buy are wrapped in, is recycled in the UK. And we eat around a credit card's worth of plastic a day. A week. There will be more plastic in the ocean than fish by weight by 2050. And microplastics have, of course, been found in the blood, as Dannielle was talking about. From Greenr's perspective, we believe the solution is in the source of the plastic, the products we buy. It should always be to reduce as a first point of call. So over the last 20 years, the market for sustainable consumer goods has actually grown 400% compared to the average household spend of just 2%. But consumers still don't really know where to find these better impact products. Nearly half of consumers feel guilty for buying on places like Amazon, but they actually continue to do so because of the lack of sort of an alternative which offers them that accessibility. And there are some great organizations working on how consumers deal with the plastic we have in the household, and at that top level, organizations lobbying for regulation and laws on the source and the way we deal with that plastic in a sort of systemic level. And I've personally worked with 2 of these fantastic third sector organizations. However, our belief is that instead of waiting for a change in social consciousness and a revolutionary change in the way that people engage with shopping, we actually feed into that habit of sort of doing so, shopping in a way which has much less of an impact on people and planet. So Greenr brings together and vets ethical brands that sell products with a small impact. But more than that, Greenr is the home of real stats to back that all up. So with science-backed data, we're actually able to quantify the amount of waste consumers are both saving and producing. And we're really focused on building a brand from the ground up, which can break out of that eco-conscious echo chamber. There are some fantastic businesses that are already tackling issues at source, and we have sort of a prospect list of over 600 in the UK alone. So there's great work being done at a business level on this. And I mean, Cheeky Panda's here, one of the best. One of the biggest issues with the way that people buy is that they purchase what they're used to and what they believe is good quality. Traditionally, the eco-friendly movement has a certain stigma to it, a certain stereotype, and that's super outdated and frankly incorrect. However, to bring more people into this movement, you do need a relatable brand that allows people to feel welcome regardless of their social identification. So we already have a strong brand and sort of IP built for that future. And in fact, our main channel, Instagram, we have over 7.5 times the engagement of our closest competitors, showing that we're really focused on that engagement level from a consumer perspective. But shopping isn't particularly innovative. You know, we need to reduce consumptions. And even though we're all looking at hugely impactful ways of reducing consumer plastic, you know, not only that, but consumers don't necessarily trust the claims by companies. And this is why we've built the UK's first marketplace platform to have an innovative impact calculator with data showing how each product stacks up against the mainstream alternatives. So with that science-backed data on carbon emissions, water, plastic saved, we're putting an end to wishy-washy promises, sort of giving us that unique edge and a pathway to measuring our overall impact. Of course, the government's Green Claims Code shows it's more important than ever to provide clear evidence to back up your claims, and younger shoppers are actually more conscious of this than ever and leading that drive. On our platform, you can shop by category, value, or by space, making it accessible whatever your priority is. And we've been laying those foundations to allow us as a business to scale rapidly to become a household name that people love and use regularly. It's all very well talking about the way, you know, changing the way people shop, but it's super important to note that this isn't just impactful ambition, but also the capital is already being spent looking for these products. We're here to make that even more accessible and propel that into the mainstream. So there's no better time to be behind companies that are focused on the future of sustainable shopping. The industry is growing. There's already a £10 billion addressable market of sustainable FMCG products right now in the UK, and almost a third of that takes place online. And of course, the pandemic has like supercharged both of those markets. And it's not just consumers getting behind this trend. We've seen new legislation coming out more and more frequently. Public figures from all walks of life. It's no longer just Greta, Greenpeace, and Extinction Rebellion. And when we talk about engaging consumers in a new way to shop, it's really important to understand consumer habits, who your consumer is, and what makes them tick. So my co-founder, Hugo, has spent a huge amount of time creating a detailed and focused marketing strategy and plan that lays out our implementation strategy. So not only this, but we've broken down those consumer profiles to the nth degree. So we know who we're talking to and how to convert them to buy, you know, stop buying from companies that don't care. And one of the things that resonates with consumers the most is relatable partnerships, right? So they want to see more than data. They want to see more than a calculation to reduce their waste or impact. So leveraging partnerships with big brands can net us big audiences for that exact reason. So we've already partnered with Surfers Against Sewage. We're fulfilling our B Corp application. We're working with Google award-winning 3 times digital agency Panton partnership. And we're working with Ecology, one of the biggest tree planting and climate education companies in the UK. if anyone on this call wants to sort of help greenr.co.uk on its mission, we're in a super exciting time at the moment. So we're actually raising for our launch in August. And I've hoped that, you know, I've shown that we have a team, plan, partnerships and vision, as well as traction in place for that launch. But of course, for us to sort of bring a mainstream marketplace into the sector, we need the capital to convert more consumers quicker, efficiently and effectively, because you know, this is an imminent issue. Working with Greenpeace, Surfers Against Sewage, the government, local government, and now business, these things are becoming more pressing, and we do need to sort of offer consumers a different place to shop. So we're raising £350,000, and that will give us that runway for a year just to do just that. And this is the time to be part of that greener journey, really. We're looking for people who can sort of see that vision, the market, the longer term plan we've laid. And this is a really super exciting space, right? There will be a sustainable marketplace that disrupts the industry in order to reduce plastic waste. We believe that that is greenr.co.uk. So, you know, please do feel free to reach out to me or my co-founders for more information about Greenr or anything else that I've previously worked on. Thanks so much, guys.
Super, thank you, Thomas. And so after you, we'll have Giovanna from Naturebeads.
Hi, hello. Let me share the presentation. Good morning, everyone. I'm Giovanna, the CEO and co-founder of Naturebeads, and we are creating a platform of cellulose solutions for a green planet. We heard already today a lot about the issue of plastic pollution, and my presentation focused specifically on microplastics. As Dannielle said, it's the most abundant solid waste, and the problem with microplastic is that because of their small dimension, they are airborne, and they've been found in the food we eat, in the water we drink, and in the air we breathe. And we are getting used at headlines like this in the news with microplastic found in the oceans, in marine organisms, and in all sorts of environment. But most recently, researchers have been focusing really on the effect of microplastics on humans. We heard already from Dannielle, you know, plastic microbeads has been found by researchers in human placenta, in lungs, in blood. So and the effect on human health, we are just starting to understand. So probably some of you have heard of a specific type of microplastic, which are microbeads, because microbeads have been banned in cosmetics, and environmental groups like Beat the Microbead and the Plastic Soup have lobbied to ban plastic microbeads. Why starting from microbeads in cosmetics? Because plastic microbeads used in shower gel or toothpaste, if you think about it, they have a working life shorter than a plastic bag. 5 minutes, you have a shower, they end up in the drains, and because the wastewater treatment plants are not designed to filter such small particles, they end up in the oceans, and they are eaten by fish that they end up on our tables. And since we started our journey with Naturebeads to address microplastic, a lot of people have asked me, like, but plastic microbeads in cosmetics have been banned, so why we are still worried about them? So if you look at this map, you can see where the problem is. First of all, plastic microbeads have been banned only in some countries, which are indicated in this map. So there are a lot of other countries where plastic microbeads in cosmetics have not been banned. Second, even in countries like in UK, where they've been banned in cosmetics for all different functions, they are only banned for rinse off cosmetics. That means, you know, shower gel, body scrubs, but they're still used in leave-on cosmetics, products like makeup or sunscreens, for example. Then there are countries like in US where the ban is even narrower, because they've been banned only for a specific application, which is exfoliant. So the truth is that plastic microbeads are still used in cosmetics. And to make the problem even bigger is that plastic microbeads are not just in cosmetics. They've been banned in cosmetics because they are single-use plastic in a way, but they're still used in paints where they have a longer life, because a paint can stay on the wall for 10 years, but eventually they end up in the environment when the paint is stripped off. They're used as abrasive in detergent, they're used as additive for the oil and gas industry, they're used as fillers in composites. So the problem is much bigger than we actually even initially imagined. So what we're doing at Naturebeads is that we want to prevent the pollution by microplastics, intentionally small particles, by replacing them with particles made of cellulose. So the advantage of cellulose is that it's a natural biopolymer, so it is a plant-based ingredient, is renewable because every year the earth produces millions of tons of cellulose, and it can be sourced sustainably from sustainable forestry, perhaps in the future also from agri-waste or from side streams of production like nappies or from cheeky panda, and is biodegradable, so it doesn't harm the environment. At the same time, though, because it's a biopolymer engineered by nature to be resistant, is also chemically, thermally, and mechanically resistant. At Naturebeads, what we do is that we take natural cellulose, which is available in fiber, and we transform it in spherical shape so that it can be used as an easy drop-in replacement for spherical plastic particles or microbeads. And because cellulose is also an inexpensive raw material, we aim to be price competitive with plastic, which is the most important thing to convince companies to replace plastic with a sustainable ingredient. So with our work, we want to impact these 3 sustainable development goals, because the problem of microplastic is not just water, it's also microplastic is in the soil. And because plastic is made from fossil fuel and it contributes to emission of greenhouse gases, we also want to reduce the amount of CO2 emitted in the atmosphere. This is Naturebeads team, and yeah, we are Naturebeads Cellulose Solutions for a Green Planet. Thanks for your attention.
Thanks, Giovanna. And now we'll go to you, Emily, for the reuse aspect of the plastic.
There. Thanks so much for having me. And it's great to hear what other people are working on. Definitely makes working in this space feel less siloed. I'm Emily Rogers. I'm one of the co-founders of REATH, where we are building the digital infrastructure for reuse. So really kind of trying to use data to power reusable packaging. Our vision is very much to build a future where nothing has to be thrown away. And in order to do that, we are looking at packaging, because businesses are turning to reusable packaging as a key way to reduce their waste and keep up with the rapidly changing market and legislation. For example, the term digital passports, where we give physical items a digital identity, a digital passport or digital twin, is coming into conversation for all physical items, including all pieces of packaging across the EU. There are aggressive tax increases planned across the EU and parts of North America, including extended producer responsibility, which will increase everyone's tax bill who kind of interacts with packaging across the value chain by up to about 10x. So it's increasing from 10% to 100% in the next coming years. And of course, as we've been discussing, there's quite a bit of increased consumer pressure around brands providing more sustainable, ethical ways to buy and consume their products. But it's hard for businesses to adopt refillable or reusable packaging. There are quite a few new barriers, including traceability and health and safety around the packaging and what's gone into it. Being able to report on the environmental impact of their reuse system and ensure that it is actually better than the single-use system, because they do have to collect and clean the packaging, which adds water usage, electricity, and miles. There are the operational challenges of the reverse logistics of getting the packaging itself back. And of course, these last 2 points go together in that reuse is new, whereas single use, well, it's not a brand new concept, as of course, we've touched on the milkman model, but reuse at scale is a new concept, and businesses really lack insights and the ability of predictability that single use very much has in terms of building systems efficiently and effectively, so that they are also cost effective as well as environmentally effective. And that's where REATH comes into play. our digital passport software makes it much easier for brands to select, launch, and scale a reusable packaging system. We work with anyone who has packaging, so manufacturers, brands, retailers. It can be B2B or B2C packaging, and it can be in any industry. So food and drink, cosmetics, home cleaning products, takeaway, and any kind of packaging lining for hot and cold deliveries or supports that items aren't damaged in transit. I'll give you an overview of how this works using one of our customers, Bauer Collective. Bauer Collective are an e-commerce business that sells home care products in these reusable pouches. So when a customer places an order, they get sent directly to their home, and then they're able to use a specially designed pouch to pour it into their kind of forever pump bottle at home. And then they flat pack the pouch and pop it in a prepaid mailer to send it back to Bauer to be collected, cleaned, and reused. REATH comes into this by giving each piece of packaging a digital identity. And we do that via a machine readable code. And in Bauer's case, this is a QR code that has a unique ID on it, which gives us the ability to create a unique entry in REATH's database. Then every time the QR code is scanned, for example, when the pouch is filled with product or when it's gone out to the customer, REATH is able to collect data on the packaging itself and what it's come into contact with. So what product and batch has been filled with, what ingredients are included in that, if there are any allergens, and it's all date and time stamped. The customer can also interact with the QR code, and by scanning it, they're able to see how many times that piece of packaging has been reused, as well as information around their environmental impact by shopping with Bauer and really understanding kind of how the system works. And of course, we can collect that data, and Bauer is able to use that to improve on their operational efficiencies and understand more about the packaging design and how it's holding up in the system after 5, 10, 20 reuses, so that they can continue to improve on the packaging they're designing and the materials that they're using. Our aim is to have the largest reuse data set in the world so that we can help facilitate the accelerated adoption of reuse by bringing some of that predictability to businesses. So currently businesses do use a REATH system to help them improve their reuse system and report on compliance measures around health and safety and traceability. But we aim to bring elements of recommendation engine functionality, support consumer engagement, predictive modeling, and of course, insights into carbon accounting, plastic credits, and tax savings, as the companies that are working hard to reuse their packaging should be supported by governments to do so. And just to touch on some data points. So one of our customers is Marks and Spencer's, and we work with them to track their fill your own hoppers, where customers can bring their own packaging into store and fill it up. We've observed that each container is reused about 144 times within a 6-month period. And each product line can save about 21,000 kilograms of non-recycled PET from going to landfill. And this all adds up to just about 1.5 million pounds of cost saves in terms of what our system can do for labor functionality and also easing the reporting needs. And to tie it all back to the Sustainable Development Goals, REATH works very closely on responsible consumption and production, which is what we're all here to talk about. And we look at that in 3 ways. We look at the carbon saved, water saved, and waste saved from a reuse system. Thanks so much.
Thank you, Emily. That's great. And so after you, we'll have Mariana from Evoralis. Mariana, over to you. I think you're on mute.
Yes, I hope you can see my screen.
Yeah,
yes?
We can see.
Great. Hello, everyone. My name is Mariana, and I'm the CSO and one of the founders of Evoralis. At Evoralis, we develop enzymes for a circular plastic economy. The plastic life cycle is far away from being circular. According to a recent OECD report, 353 million tons of plastic waste are generated each year, mainly coming from packaging and textile. Currently, only 9% of this waste are recycled, and the rest either goes to landfill or is incinerated. The main recycling approach is mechanical downcycling to lower quality products. 2% are chemical approaches divided into thermolysis or solvolysis, which often use harsh conditions or temperatures. A greener alternative is the use of biocatalysis, which are also called enzymes. The hydrolysis of the polymers by enzymes generates pure monomers, which can be then recovered, purified, and repolymerized to virgin-grade materials. Enzymes are highly specific, can deal with mixed samples. It has been estimated that the monomer production uses up to 83% less energy and around 21% less greenhouse gases are emitted in the supply chain. The enzymatic recycling process is scalable and can replace the use of crude oil. The industrial process of making and applying enzymes for plastic recycling at scale already exists. A French company showed that enzymes could be applied to recycle PET bottles, and the product monomers could be used again to produce new bottles. A bottle-to-bottle business. The most difficult part is to find efficient enzymes, especially if we consider all the different types of polymers commercially available. A couple of enzymes that can depolymerize plastic already exist, but so far, only one of them is efficient enough to be used industrially. In view of that, we have established an ultra-high throughput screening platform to find and improve highly efficient enzymes. You can find enzymes in nature or public database, which contain a huge genetic diversity. From different environments, DNA libraries can be generated, for example, from a plastic contaminated area. And these libraries can be then screened in the search for enzymatic activity. Current state-of-the-art approaches apply low throughput methods to screen those libraries, for example, using bacterial selection in plates. However, these approaches are time-consuming, require no natural substrate, and lack sensitivity. We can screen 10 million enzymes per day, which is 1,000 times faster than any current method. The high sensitivity of our screening platform allows us to efficiently select for the most active enzymes. Once an enzyme is identified, we can also improve it for optimum performance. At Evoralis, we apply direct evolution to improve our enzymes, a method which was awarded with the Nobel Prize in Chemistry in 2018. It basically consists of selecting a certain biocatalyst as a starting point and going through rounds of diversification, screening, characterization, and selection in order to find an improved candidate. Each round increased the chance of additional improvement. By applying our screening platform, we observed 5 times improvement in activity for a PETase in one round. Our journey initially started with 3 postdocs at the Department of Biochemistry at the University of Cambridge. Last year, we founded Evoralis, and this year, we submitted the patent applications of our technology. And we are one of the finalists at the Emerging Technologies competition from the Royal Society of Chemistry. We are a multidisciplinary team that consists of experts in high-tech commercialization, chemistry, biology, high-throughput technologies, and protein engineering. With that, I finish my talk, and I would like to thank the organizers of this event for having me here today, and also you all for listening. I'm open for questions. Also, please feel welcome to email me. I hope you join us at this journey for contributing to a circular plastic economy.
Super, thank you, Mariana. And now moving on to the last speaker, Mike from Change Plastic for Good. Mike, over to you.
Thank you very much, Ariane, and thank you everybody else that's presented before. So I want to spend a lot of time talking about the problems of plastic pollution. What I'll do is present what potentially is one of the solutions as part of the journey to moving to a much greener and much more sustainable society and ecology that we have in the world, hopefully. So the organisation I belong to is called Change Plastic for Good, and we change plastic for good through technology and action. So next slide, please, Ariane. So the core of our business is around a technology called BDP, which originated in the biomedical industry in the early 90s with biodegradable sutures, and that technology has been advanced and evolved on through some smart guys, much smarter than myself, into the plastics industry. It was developed on a commercial footing rather than academic footing, so the background is more patent and commercial than it is anything else. But what the technology has become is a biotechnology that is effectively an additive that you would put into any regular plastic, as long as it's polymer-based and has that kind of organic structure, effectively making the plastic or the polymer in which it goes into almost a sugar-coated candy for naturally occurring microbes. What this does is it allows microbes to identify any plastic that has this additive in as a food source, and effectively they want to eat it in preference to any other material around them that doesn't have it in. One of the benefits of this biotechnology, it is dormant until it is environmentally activated, so it requires the right kind of environment to be activated. Typically you'd find in a anaerobic digester or in some of the more advanced composting facilities that are out there. What we present this technology as the core is more of a fail-safe solution, but we know it has more legs and arms to this. But what it does is it gives a better end of life for polymers that can no longer be reused or recycled through current methods, or that those have escaped the system. So we've talked an awful lot about plastics that have escaped into the environment. What this does is it gives it a much better end of life scenario, because it does speed up very, very significantly this whole idea of natural biological attack of the products or the plastics that are in there, turning them into much more innocuous and naturally occurring types of products that come from that. It also doesn't necessarily prevent microplastics, but what it does is it makes them much less persistent in the environment. So microplastics are an inevitability of losing plastics out of the system. The environment will make microplastics whether we manufacture them or not. But what this does is, as the surface area to mass ratio improves, as in effectively the sizes get smaller, it gives more surface area for the microbes to attack and eat that away. One very exciting area that we're getting into at the moment is we also know that this technology works on rubber because the structures are very similar. So this type of technology has an awful lot more arms and legs to it. So we think we're only really scratching the surface of where BDP actually can go to and what it can be applied to. So, you know, invariably watch this space, have a look at our website. We do press and put up a lot of information there. So next slide, please, Ariane. So why do people want to use BDP? Well, there is a lot of background in additives plastics, especially some of the bad ones that have turned up in the past. But what we do say is we're very honest about what we do, which comes out in the next slide, which is, you know, it is from fossil oil, but it's actually extracted from byproducts from the oil industry. So some of the things that would normally be discarded or burnt or put away, these are recollected, they're reformulated and put back into the plastic, particularly to give it the properties that we want. We also know we can biosource these, but at the moment, we think it's better to get them from fossil oil until we can deliver a better biosourcing environment. Because they're sourced from fossil oil, they're also very compatible with plastics because they're effectively from the same feedstock and the same kind of chemical family, if you want to call it that. So what this does is it imparts things like a very much an unrestricted shelf life. So we've had products that have had these components in for 7-10 years that are on test. They're still particularly inactive in those environments, but obviously if they reach the right environment, it's very similar. It's very safe, it's very compliant, and it's very easy to use. So it has all the safety regulations, so you can use it in food contact and everything else. And also when you add it to any material, polymer, it actually, with some help, we can make it functionally identical to any component that you'd make out of it. It's very circular. And all the testing we've done to date, we know it's as reusable as any other polymer that doesn't have it in. So a like-for-like substitution, it has exactly the same reusability and also recyclability. We haven't found any issues with recycling as yet because of the addition rates and also the nature of the material that's in there. And from a commercial footing, we see this as being very cost effective. It's targeted at FMCG. It's in a convenient format, so it's typically added at the same time as you would add something in like a colorant or any further sort of late stage processing aids into a polymer manufacturing process. There's also minimal investment because it does come in a very convenient form. It typically fits in with what's already there. So we're next with BDP. So we have a lot of effort into our R&D. So we're looking at the formulation and moving that on. We're up to 100 formulations, depending on the material that it goes into. We're developing better and more sophisticated anaerobic digestion facilities. The idea is we want to develop closed loop systems where material that has this in can come back and be effectively biologically recycled, whether it be into other materials like gases and other material that could be used elsewhere, or whether it be broken down into monomers is part of what we're looking at. The microbiology associated with this, but also the material science. So how do we make this work better? How do we reduce the amount that's in there to get the same kind of benefits that we would have to buy it in the current amount that we do? We also want to develop these closed loop systems. So when we talked about tires earlier, the idea of a tire is, you know, two things happen to it. It wears away, the parts, components go into the environment, but the other components often are left in the tire and they need to be recycled somehow. So if the little bits, what we call city gas, or the city particles of city dust ends up in the environment, those should break down because their microbes are attracted to them. But also if we were to put the tires into an anaerobic digester, the nylon support structures and the rubber would be broken down by the microbes and the environment within that, but it would leave the steel radials, which could then be recycled with the steel and the other components recycled elsewhere. So that's, you know, one of the reasons that we want people to use and begin to adopt, at least look at BDP, breakdown plastic, as our core technology of what we want to do. So next slide, please, Ariane. The other side of our business is about what we call the Change Plastic for Good movement. And it's all about promoting what we do correctly. So we know we are part of the solution, not the only solution. There is a wider picture on this. You know, we champion action for the environment. We're very much anti-greenwashing. We can't stand things that don't really make sense and go down that route. We also champion transparency. So we're very open about what we do. We don't quote numbers, we actually quote circumstances and very specific examples which are close to what people ask for, rather than saying it's 1,000 times better or 100 times better or 10 times better or whatever it is, because it's just not accurate enough. We have a thing with what we call our gold standard, which is the idea being that we want to become the benchmark for what people say and how they communicate and how they work with this. So as we support the EMF in their new plastics economy principles, we want to be there that say, you know, we do fit to this for our customers and consumers. We also want to champion a gold standard in education and clarity for responsible plastic use. Plastic is great, we just need to use it and manage it better because we haven't done for many years. We really need to address that. We also find that we need to be a gold standard for things like standardized testing and action. So there are a lot of standards out there, they're very difficult to navigate through sometimes, and very difficult to understand. We really want to champion the idea of making that much clearer for people to get their head around. The other side of that, and just to finish this kind of story off, is we do support action for cleaning up legacy plastics. We know that our technology doesn't fix what's already out there, but what we can do is we can clean up the stuff that is there. So we support things like a Plastic Ocean Foundation and Pilot for the Oceans. But what we do is the material that we do collect, our technology works if that material is not available for recycling or reuse, because even with damaged plastics, our technology will make that much more biodegradable in an anaerobic digestion system. So that's where our system works. That's what we talk about. That's our technology. So if you just move to the last slide, please, Ariane. I'd just like to say thank you very much. And our little motto for this particular exercise is float like a butterfly, butterfly being our motto, and clean up the sea. So thank you very much, and back to you, Ariane.
Hi, Mark, super, thank you. So that's the end of the speakers for today. We have a couple of questions. So the first one was for Chris, actually, from Cheeky Panda. So Chris, if you're here, the question was, how does Cheeky Panda compare to Who Gives a Crap?
We were the first UK bamboo tissue business. Who Gives a Crap? We're doing recycled tissue. An Australian company, so they kind of copied us in the UK with the bamboo tissue, and they've wrapped their individual rolls in paper, where we just have regular tissue. I think if you go online and sort of see the number of reviews that we've got, which is well over 20,000, you'll find that a lot of people prefer our products. So I just do your own research is what I would say. But yeah, we were the first ones to do it here. They copied us.
And you've had a few positive comments in the chat section saying that the products was better quality. So
yeah, I mean, who wants and it's quite a crude name. It's very Australian. Who gives a crap? You know, it's quite funny, but it's quite crude. So I mean, I think Cheeky Panda is a bit more sort of into the family and a bit more sort of friendly.
So right, and then after that we had a few questions for Thomas. Thomas, you've answered most of it on the chat section, but if you want to add any further comments, then this is the time to do so. So yeah.
Well, yeah, I mean, I think I've mainly answered them in the chat. Obviously, I'm always happy to speak to people off platform as well to save time. I think what I would just add about competitors is that we're incredibly, I guess, grateful is the word for the work that's been done by, you know, the first sustainable marketplaces, you know, in the sector to start bringing brands together. What we need to see now is a move away from your, you know, pigeonholed type of brand and more transparency around it as well. So, you know, with various regulations, consumer demand, and businesses demanding more transparency, that's what Greenr brings. So it's a place which resonates with more people, but also, as you can see from our engagement, right? So the 7.5 times is actually to the nearest competitor, but it's far more that on most of the competitors. I'm happy to share that information, but then also the transparency, right? Like the first marketplace platform to have an integrated, you know, personalized impact calculator. We're not using other people's, we're using aggregated scientific data done by universities to bring that sort of transparency to consumers and brands. So I think that's what's really important from a consumer point of view. Or they will really engage with that is their own data, the community's data, but also in a really fun and engaging and gamified way, right? Like from a business perspective, we can utilize that to get people to swap out more products to more sustainable ones. So yeah.
That's great, thank you. Yeah, quantification is definitely super important right now. And so yeah, just one last question and then we'll move on to the breakout rooms where you can have more of a one-on-one conversation with the speakers. So the last question was from Emily, and it was, does changing to eco packaging significantly reduce profit margin? Is this why big corporates might avoid? I don't know if Emily or Daniel or anyone else wants to have a couple of words on this.
I'm happy to share from because I guess there's single-use, more sustainable packaging, but we focus on reusable packaging, which is usually a more expensive upfront cost for brands to develop because it needs to be more robust and has to stay in life for much longer. But the benefit of that is that if they have a higher collection rate, you know, between 75 and 95%, then they actually save money over the lifetime of the packaging because they're able to reuse it several times instead of buying in new. So it's more about demonstrating to them how you can amortize the cost over time to kind of ease the brunt of paying up front.
I mean, a lot of Boston Consulting Group's clients will be these big corporations. So show me how someone's paid and I'll show you how they're motivated. There's a lot of other data out there outside of BCG where actually show that consumers are actively switching and paying a slightly premium, although it has to be within 20% is the threshold. They won't pay double, but if it's within sort of 10 to 20%, actually the adoption is quite high. But obviously they can't tell that to Coca-Cola or Nestle.
Does anyone else has a last comment? If not, we'll move to the breakout room shortly.
Hi, Ariane, there was a question for me from Dannielle.
Yeah. Sorry, go ahead.
I'll just cover that very quickly, hopefully. And thank you for the question. A very interesting question as well. I was just having a response, hopefully, to get to you at some point. But what BDP technology is actually based on organic chemistry. So it's a kind of chemistry that is extracted from oil. Effectively, it's the nutrients and some of the other compounds that were trapped in the oil millions of years ago when it was all compounded under the earth And as the anaerobic digestion process went on to produce natural gas, coal, and the oil, some of those nutrients are left, and that's what's extracted from the oil that is extracted by us and made into other products. So we take some of that back and we put it back into the plastic, reformulated and rebalanced, so it actually does the job we want it to do. So our technology is not based on transition metal salts. It's not oxo technology. It's very distant from that. And also, we're not time valued. We're not time limited. Our technology can last for a long time. It doesn't have a particular shelf life before it begins to activate. And also, our chemistry, because it's full with the original polymers and also the families of polymers that are out there, we have only found 1 or 2 that it doesn't work with, and it's all the regular commodity ones. The chemistry is compatible, so when you recycle them, because our addition levels are very low, it doesn't devalue or contaminate the recycler. So we have benefits in being able to do that as well. So there is a threshold of addition where it doesn't work, and that's the kind of level that we dance with the commercial side of it as well as the performance side of it. That's where we have 100 formulations, because sometimes we get it right and sometimes we get it wrong. You know, we're quite happy to admit that, but the benefit and the advantage at the end is it always does the job we say it does, and we do that with testing and with background data that we have.
Can I just quickly add something to the cost question? One thing that's been really clear over the last 20 years is that the cost of sort of eco-friendly products has changed quite a lot. So traditionally, when you think of an eco-friendly product 20 years ago, it usually wasn't great quality, or it was luxury quality. So it was expensive, or it was super cheap but crap. Whereas now what's happening is you're getting a whole bunch of startups and brands which are creating products which are better price point for equally good quality to their mainstream counterpart. So even though at the moment, as Chris says, there's still that sort of maybe maximum 20% markup for the ones that are doing it well, that's actually going to decrease. And what's also really exciting within that, one of, things that this group will know, but also I went to a Google for Startups event the other week, is the tech that's being developed at the moment to make these things even more accessible and more affordable. That's really exciting, because then you can actually create more sustainable packaging products, materials at a much cheaper price point than actually their mainstream competitors. So in 10 years time from now, what I'd like to see, and I'm fully expecting to see, is actually sustainable products will be even more affordable than their current mainstream competitors. We're not there yet, but we will get there. And that's why, like, being a part of this movement now is the most important time to be a part of it, because the ones that can sort of innovate at this period will be the ones that sort of lead that way in that future market. So yeah, that, I think, yes, there's a price point difference, but that won't be an issue for very much longer at all.
Great. Thank you, Thomas. And I think no one else has any comments on that topic. So what we'll do now, Sylvie, if that's okay, is we'll open the breakout room. Martin, I don't know if you want to say a few words before we jump in the rooms.
You're on mute, Martin.
Thanks, Oriane and Sylvie. I think a very interesting event. Good commentary from the presenters, of course, and some initially interesting questions. But I think if we go into the breakout rooms, we can take the conversation further. Thank you to everybody.
Thanks.